right, guys, so let's take a look at 3.1 part 1. This is polynomial functions. So we're going to talk about some key parts of your polynomial functions. Your an is this leading coefficient, and it cannot be 0. All right, leading as in it's on your highest exponent. So n is your degree. This is your highest exponent. That's the degree. Usually they write that first. They write from highest exponent down to the lowest. And then the little subscript here, a naught, that is the constant term. That again, they are decreasing your degrees, or I guess your exponents, all the way down. So once you get to an exponent of 0, like you have 0 x's at the end, then you've got your constant term. All right, so let's talk about some kind of rules here. Your an cannot be 0. So like this an right here, what I'm multiplying in front, can't be 0. It would totally eliminate your x to the n. It would totally eliminate that nth degree. So it cannot be 0. Exponents are all positive whole numbers. So these exponents right here, n or n minus 1, n minus 2, these all have to be like a power of 2. This is actually, they didn't write the exponent, but it is x to the first, so it is a positive whole number. And this one, they didn't even write an x, but it's like x to the 0, like I have 0 x's. So these are my positive whole numbers, or equal to 0, I should say, from 0 up. And then your coefficients, the coefficients are what you're multiplying in front of your variables. All this a with a subscript, like a2, a1, a0, all those a's, those coefficients, they have to be real numbers. They can be messy real numbers. They could be negatives. They could be fractions. They could even be like these crazy decimals, pi, you know. So as long as it's a real number, no imaginaries, then it can be a coefficient. It was the positive whole numbers for your exponents. They have to be like a 2, 3, 4, so on, but nice positive exponents. Actually should put 0 as well, so maybe not just positive, but you're 0 and up. So let's use those to combine like terms. Your definition of like terms, your like terms have the same variables to the same exponents. My variables are like the letters. So let's talk about the same variables. Like, let's see, on this guy, I've got an a and a b. Those are my two variables. And so let's see, which ones have an a and a b? This one, 2ab. This one's got an a and a b. I think those are the only ones with the a and a b. So let's have the same exact variables. And let's see if they are, in our second requirement here, if they're raised to the same exponent. So this is, if they didn't write it, it's to the first. It's like a to the first, b to the first. All right, a to the first, b to the first. This one wrote the b, it is to the first. A is also to the first. They wrote it in a different order though. Does that matter? No, it does not. Because they are multiplied, a times b or b times a, you can multiply in whatever order you want. And so, yeah, order does not matter for multiplication. So these actually are like terms. So let's go ahead and combine our like terms. When you combine your like terms, you are going to look at the coefficients, like the numbers in front. So I'm going to look at combining my 9 and my positive 2, so like 9 plus 2, and my negative 5, so like minus 5. 9 plus 2 is 11, minus 5 gives me a 6. So I'm going to get the coefficient of 6, but the same variables to the same exponents. So I'm still going to have an a and a b. You could put ab, you could put a ba, either way. They're also still raised to the first, which honestly, you don't need to write an exponent of 1. I could just call it 6ab. So those guys were my like terms. Let's see if there's anything else. Let's look at these guys, my a squared. Are there any other same variables, any other straight up a's raised to the same exponent, so squared? And I think there's this guy as well. So I have actually 2 of these like terms right here. And then to combine them, I'm going to do, like I said, add the coefficients. So this is a coefficient of negative 6. And the other coefficient they didn't write. It's because it's multiplied by 1, really. They're not going to tell you times 1, because you can multiply by 1 all day long. So they'll just write the a squared, but the coefficient is technically a 1. And I will combine like terms by adding the coefficients. So negative 6 plus 1 is a negative 5. So there's my new coefficient on the a squared. Okay, so the ones that I circled, I combined those guys. And I think the only thing I haven't used yet is the negative 7b squared. I don't see anything else with just a plain b, especially a b squared. So I think that guy is by itself. It's just still going to be a negative 7b squared. Okay, so this is totally simplified. We combined all of our like terms. All right, so then next one, we're going to fill in the chart here. If you have a constant, that just means like your straight up number, I could have, 7, sure. If you have a linear type of polynomial, like it's got a plain x, I still need a coefficient. It can be, maybe a negative coefficient, sure. So like negative 2x plus 7. There is an example of a linear polynomial in standard form. My quadratic has to do with, it starts with a degree of 2. So it goes like 2, 1, 0. Like it's like maybe a 3x squared negative 2x plus 7. So that is a quadratic type of polynomial. Cubic, as in cubed, your leading, or excuse me, your degree 3, like the highest exponent is a 3. So that would be cubic. And we're going to hit every exponent on the way down. You can even start with something messy. I could start with like a 0.5 in front of my x cubed. I can do that. And then I'll hit every exponent on the way down. There's my cubic. Quadratic, or excuse me, this is a quartic. Quartic, like quarter, there's the highest exponent of 4. And again, you can have messy decimals. Maybe I'll go with like this messy pi. It's like this infinite decimal. But I'm looking at quartic, like its highest exponent of 4. And then I will go down to an exponent of 3, 2, 1, and 0. There we go. So here's some examples. And let's see if we can pin this information on these polynomials. So first of all, decide whether the following polynomial are polynomial functions. It's kind of a yes or no. Is it a polynomial or not? And I'm going to say, let's see, I've got the leading coefficients. Let's see, those are, or sorry, all of the coefficients, all those guys, those can be messy numbers, that's fine. Exponents have to be whole numbers, which let's see, I got 3. This one is an exponent of 1. All right, and then, so all my exponents on x, those are good. This is a polynomial function. So I'm gonna go yes on this guy. I do see a messy coefficient, but that's okay. I can have messy coefficients as long as they're real numbers. So those actually are all real numbers, that's fine. My exponents have to be nice, pretty whole numbers, which I think those 3, 4, yeah, those are whole numbers. So yes, that one is also a polynomial. All right, coefficients. -1, I know they didn't write the 1 there. Got a 7, got a 4. Okay, so the coefficients are fine. Exponents, those are supposed to be whole numbers, which I think they are whole numbers, except for this guy's a negative. So for that reason, this is causing a problem. My answer on this one is no, it is not a polynomial because of the negative exponent. Number 5, let's see here. Yeah, number 5 has, let's see, 1 for leading coefficient. The 3 is actually not a leading coefficient. They both have a coefficient of 1. And then my exponents, though, problem, pretty whole number of 2, nice, nice, but the x, if it's raised to not just a whole number, it's not even a number, it's a variable that they have as their exponent. So no, it cannot be a polynomial function. Okay, so the first 2 are yeses. So we took care of this. Decide whether the following are polynomial functions or not. So if so, write in standard form. So on the first 2, those yeses, let's put them in standard form. The standard form has to go highest exponent to lowest. So let's see, 3, this is an exponent of 1, and then I've got 0 of the x's at the end here. So actually, I'm going from highest to lowest, 3 and then 1 and then 0. I skipped an exponent of 2, but that's fine. I was in descending order, so that works. Standard form is kind of check here. Here's my standard form. The standard form of the next one, again, I'm supposed to go highest exponent to lowest, and I think my highest exponent in this case is 4. So I need to put that whole term, not just the x to the fourth. I got to put that whole root 2x to the fourth first. And then the next exponent on my way down would be a 3. So I got to put this whole term, including the negative and everything. Negative 0.8 x to the third. That guy comes next. And the only thing I have left is the negative 1. So it goes 4, 3, and then a constant of 1. So yeah, this is my standard form. And then they also need to state the degree, type, and leading coefficient. So the degree, this has to do with my highest exponent. So the degree, the highest exponent in this case, well, the highest exponent should be what they wrote first, which is true. So my degree in this case, highest exponent was 3. The other one, the degree in standard form, should be written first. So the degree in this one is, excuse me, not 3, a 4. Highest exponent of 4. All right, and then we've got your type. So like looking at these types here, when you have a degree 3, when your highest exponent is 3, I think that's kind of this guy, degree 3. So that was a cubic type. All right, if the highest exponent was 4, it would be a quartic. So this next one has degree 4, highest exponent of 4. So this is quartic. Okay, and they also want the leading coefficient. So let's see here, my leading coefficient is whatever's multiplied in front of that first term, like on the highest exponent. And I think the number right here multiplied in front of my first term in front of the highest exponent is a negative 2. So let's see, leading coefficient was negative 2. This guy, leading coefficient, only take this from the standard form. That's why I wrote it in standard form first. So in my standard form, the leading coefficient, what's in front of my first term, is that positive root 2. If you were looking at the wrong part, if you were looking at this guy not in standard form, you would have taken a negative 0.8, which is incorrect. Okay. So let's see, now it says evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when the x equals 3. So we are going to put this 3 in for all of the x's. That's going to be a 3. This one's going to be a 3. All those x's will be 3s. This last guy doesn't have an x. So if I put those in, I get 2 times 3 to the fourth minus 8 times 3 squared plus 5 times 3 minus 7. All right, which at this point, this is all straight up numbers, so I can put this all in my calculator. So 2 times 3 to the fourth minus 8 times 3 squared. All right, and then plus 5 times 3 and minus 7. Okay, so I should get down to a single number. There we go, 98. So evaluate when your x equals a certain number, like plug that x value in, and you get down to a single answer, single number here, so 98. All right, there we go.